Now we have all the data point, right? The next step is loading the model, this model into the simulation framework. First thing we do is let's turn it back to using the structure to capture the data. Give it an ID. And then we say in the solid model, this is important, we call it model, because and we are going to get the parts from this model, and we have to use the ID here, and we call it model, so later on we could reference it. And then where the location of the file, right? So the location is relative to where your agent runs. So in this case, we allocate this directory, and then we have this file. And it's an OBJ file. Now let's start with the scale, which I found out is when we make up this file, we probably make it really small. If you see the dimension here, it's less than 1. I think it's 1 unit. So what we want to do is scale it up. I will scale it up a little bit bigger. And the translation, we don't need to do any translation. Rotation, I will start with nothing for now and then see what the effect is. So after we've done that, we restart the agent again to pick up this new information. And then, give me a second. This doesn't look right. Oh, for some reason it didn't save it, did I? Okay, let's type it again. Did I hit cancel? Let's make sure I get it right. Let's save this one. All right, that looks better. It's loading. So you could tell it's not big, right? And also, I think it's rotate 90-degree. It's basically lying down instead of we want it to be pointing upward. So we are going to change this to make it bigger first. This just scale the rendering. It won't affect what the other relationship. And then since it's you could tell it's lying down. If you look at it, is on the x-axis. On the x-axis, if we kind of make it 90-degree rotation, then it will stand up. So this looks better, right? So at least it's standing up, and good for at least what we show it here. So we got the model. And also the way we want this to show on the simulation. So now the next step is to attach the moving parts. So let's save this one first. So we are going to first, break out the component, right? So so under structure, this is using the same convention as all the other robotic scheme. The link is describing the parts of the model. So let's call this x-axis. So where we got this x-axis from? So the item, if you look at it, is the item is called, in the OBJ file, this represents as a group. So we are using the x-axis group. The coordinate is going to be machine coordinate now. Since we are getting the data from the other model, this shouldn't matter, but just for the sake of consistent, we do it like that. The rest, I think we just use the same. I think that should be it. So we got the x-axis, and then we'll tie that to this particular axis. So we set up the motion. I think we have to use prismatic, and then x-axis is using this is basically asking the simulation to simulate the movement along the x-axis. And then the next thing is for this linear stuff, right? We have to describe which parts that we use it to make the movement. So it's a child, and then we say this is x. X-axis, okay. I see, I forgot to put this. No, I think that wasn't the issue. I just forgot to put the ID here. Let's see. Whether we see some movement on the axis, this direction, right? Or we just happen to be in a quiet period. Let's see. Oh, it's changing. 416. Oh, it's quiet period, so it's not moving. The X is not moving. Well, while we are waiting, well, maybe I will just finish up the rest of the configuration. This we are using some demo data from this machine. I think at this point, we are covering the quiet part of the simulation. Oh, okay. Well, you can see it's moving, right? So now the x-axis. So at least we see the x movement. Again, because the data is not really this machine, so you can see the table file move out of place right now. So we could pretty much do the same thing. So what I'm going to do is do it really quickly to get through the rest of the item. So we could see the entire simulation. So I'm going to do a quick cut and paste, so easier to modify that way. So that set up all the parts. Let's tie to the movement. Um, the axis here is kind of strange. I'm using Y as the movement because we rotate the model 90 degree. So that the Y movement become the X movement. So and then I'm going to specify the relationship too. We could take a look at where we are now. So we have X and also Z is supposed to move. So let's see whether, well, Z is not moving much. Yeah, now you can see the Z is actually moving, but you know, it detached from the other things, right? So it's only this Z axis moving. So the rest of the stuff. X should be moving, but now X is kind of quiet, not that much move. So you don't see the that, you know, unless you see the big data change. So let's try to get the rest finished. The C, this will be a good example too. So C is, this one is rotation, so it doesn't matter what type of. This also it doesn't matter. So, and then we say, now this one, we want to attach this to the Z axis because we want that to move along with the vertical location, right? So we're going to say the parent is going to be the Z axis. Let's see where they move the X, Y, the Z. So you can see now this move along with the Z axis. So we have one left, which is the, we got X, now the Y, right? Now this one is Y become Z, since we did the rotation. We restart it. And, you can see the Y moving, right? But then you notice the X is not moving along with Y. X supposed to be on Y, right? Because we want this, when we do the X movement, it kind of have to anchor it on the Y, whatever that position. So that's one last thing we need to kind of tie that is the, is really the X1 is tied to the Y. So that means this has a parent. what happened? Y axis. Oh, something's changed. Why this is called X axis 2. All right, I think this should be it if we do it right. Yep, you can see, I think that now the X also move along with Y, then the Z is kind of moving up, up and down with the rotary. That, well, I mean, even the the data is coming from another device, but you could get all the axis movement that we want. Here we can't see the rotation, but this will also rotate according to whatever the C position. So that's about it. I mean, we can look at the generated XML file, which is here. If you handcraft the device XML information, this will be what you have to put that in. So we do that using the UI to do all that work, but if you want to do it manually, this will be the content of the device XML that you have to set up. Yeah, that's pretty much it.